Hello. Now we are going to be looking at how to graph and describe sine and cosine waves via the sine and cosine functions. So for starters, let us take a look at what this format is going to look like. You've got y equals a times the sine or cosine, either one will plug in just fine here, of omega times theta. And what I'm going to be asking for you to find is the amplitude, which is this a. So if you have a equals, well, you find the amplitude. Whatever the number is right here, that's your amplitude. That is the amount that the wave is going to stretch up to in the positive and go down to in the negative. And we're going to see how this looks in just a couple minutes here. And I'm also going to ask you to find the period, t. And the period is found via a simple formula, 2 pi divided by omega. And you get your omega from your function, from your equation. The omega is whatever is times your theta. So take this omega, take 2 pi divided by omega. Whatever that is the length of the period. The period is the amount of x on the graph that it takes to form one full wave of sine or cosine. And again, we're going to see what that looks like in just a moment here. Well, let's take a look at how to do this with a sample. So we've got 7 times the cosine of 3 theta. We need to find the amplitude. What is our amplitude here? Amplitude is whatever is times your sine or cosine function here out front. That's going to be 7. Amplitude pretty well sticks out. And our period. Again, our formula is 2 pi divided by omega. So I'm going to take 2 pi over, for omega here, we're going to plug in 3, because 3 is what is times theta. 2 pi over 3. That does not reduce at all, so that's it. It takes the amount of 2 pi over theta in order to form one full cosine wave. 2 pi over omega, 2 pi over omega. Okay? Let's take a gander at another one. That's a little bit trickier, but not too bad. Okay, first thing, amplitude. What is our amplitude? We've got the 4 out front here. 4 is our amplitude. Boom. What is our omega? Because we're going to need our omega to get this t from our formula, 2 pi over omega. What is the omega here? Be careful, because this omega is not 5. We're dividing by 5. And really we can rewrite this as 4 times the cosine of 1 over 5 times theta. This 1 over 5 is our omega. It is not 5. If you see theta divided by a number, then you must take that number as a fraction times theta. You cannot just say 5. This is a pretty common mistake. Please be aware of this. So notice how I pulled out that 1/5. This 1/5 times theta is the same thing as theta divided by 5. So I plug this into my formula. I've got 2 pi over 1/5. And remember, whenever we've got a fraction that we are dividing by, we're just going to take our numerator, 2 pi, and multiply it by the inverse, the reciprocal of what is on the bottom. We're going to flip that guy, so this becomes times 5. And put the 1 on the bottom. We've got a 1 underneath here because any integer is over 1. And we multiply straight across. 2 pi times 5 gives us 10 pi. And everything is over 1. And this just becomes 10 pi. That's it. So our period for this equation is going to be 10 pi. Now I'm also going to ask you to be able to graph these. And these will look something like this. If I've got just a standard equation for sine, y equals a times the sine of, let's just for clarity's sake put parentheses in there, omega times theta, I'm going to have a wave that looks like this. And there's a few key points that we're going to see that we can use to graph one full wave. First of all, as we said, the amplitude determines like how big the wave is going to be, how high it reaches, how low it goes. So in the positive, it goes all the way up to a. So this point right here, the maximum of the function, is going to be at a y-coordinate of whatever a is. So if your amplitude is 7, this would be 7. If your amplitude is 42, this would be 42. Similarly, it's going to hit the minimum down here at negative a. And we can get a good idea of what one full wave is going to look like by graphing a few points. We've got our y is pretty well determined here. We know this y point right here is going to be at a. So we can put that in. Let's also focus on this point. I'm interested in where that one's going to hit the x-axis. And our y value there is what? If it's on the x-axis, well, that's just 0. And then over here, we know that our y is going to be negative a, because it is down so low. And up here, we are back to, with the sine function, back to 0. So let's see if we can find out what these x-coordinates are going to be. A period is the full length of time it takes to do one wave, one full cycle. So if we're using t for our period, well, hey, in order to do one full cycle, that's just going to be t right there. And in order to get these nice, neat points here, well, we can just divide this into 4 pieces. Here's 1/4 of the equation. Here's the 2nd quarter. This will be the 3rd quarter and the 4th quarter. So we're just dividing this t into 4 parts. So right here, my x-coordinate would be t over 4. That 4 is backwards. I'm writing upside down. This would be t over 2. This one is 3/4 t, so it would be 3t over 4. And then, like we said, that's the full thing, that's t. And how this would look, if we've got an equation, like let's say we've got y equals, how about 5 times the sine of, let's do 3 theta. So we know that this a up here, well, that would be 5. Down here, this would be negative 5. Let's find what these x values would be. Well, we've got t over 2. So we need to find, to get this, or excuse me, t over 4. Let's do the first one. In order to do t over 4, we need to get the period. We need to find out what t is first. So we use our formula. T equals 2 pi over omega. Well, we know that our omega is 3, so the period is just going to be 2 pi over 3. We can't make that any simpler. So we can do t over 4, and notice we've got a fraction here. we can do 2 pi over 4. That gets a little bit messy. What we can also do is we can rewrite this. This is just t times 1/4. Okay? T multiplied here would be, the t would go on top, it would be divided by 4. So I think writing it like this is going to be a little bit simpler because we're dealing with a fraction with this 2 pi over 3. Let's plug in for t. You'll see what I mean. I've got 2 pi over 3 times 1 over 4. Multiply across. 2 pi is on top because 2 pi times 1. 3 times 4 gives us 12. And then we can reduce to simplify this. We just get pi over 6. So our first coordinate here, the x, would be pi over 6. And we already said that a is 5, so it would be pi over 6 times 5. Or excuse me, pi over 6 comma 5. T over 2 is the same thing as t times 1 over 2, which is 2 pi over 3 times 1/2. Multiply across, we get 2 pi over 3 times 2, 6. This just becomes pi over 3 after we reduce. And our last one, this 3t over 4, this one, splitting the fractions apart here really makes it a lot simpler in this one, otherwise it becomes a big mess. Take your t, multiply it times 3 over 4. This is the same thing. These are both the same. These are both the same because you're taking t. T would go up here in the numerator if you multiplied them together and put them on the same fraction. So we get 2 pi over 3 times 3 over 4. Multiply across on the top, we get 6 pi over 3 times 4, 12. And reduce, divide by top and bottom by 6, we get pi over 2. And then our last one here would just be t, which we already said, well, that's 2 pi over 3. And then we can go back and we can fill in for all of our points. This would be t over 2, well, we said that one was pi over 3, so that's pi over 3 would be our x, and our y is still 0. 3t over 4, we said that one was pi over 2, so this is going to be pi over 2, negative 5. And then our last point, our t is 2 pi over 3, and the y is 0. All sine waves, if they are positive, are going to look like this, and they're going to have the key points right there. We can do almost the exact same thing and for a cosine, except the big difference is cosine, if it's positive, is going to start on top. And then it's going to go down for its first point. It's going to intersect the x-axis. It bottoms out right here, halfway through completing the cycle. 3/4 of the way of the cycle, it hits the x-axis again, and it goes all the way back up to its starting point on the y to complete the cycle. And when I ask you to graph, I'm just going to ask you to graph really one full wave. I want you to see that you've got a grasp on this one full wave, and then the waves will actually repeat for infinity. But show me one. All your waves will look something like this. If the sign is positive, if your amplitude is positive, what is here out in front is positive. If you got positive all the way across, it's going to start going up, come down, and complete. It goes into the positive first, and then it goes into the negative. If you've got a negative sign, or if your omega is negative, for sine it's going to start going into the negative first, and then it will come back up and complete the cycle. Again, we've got the same main points here. Those don't move. Right there, there, there. Those don't move. It's just which direction they're going in first. Cosine, same thing. There's our main points. Starts off positive. And then for if cosine should be negative, if you happen to have a negative amplitude, it doesn't really make a difference what the omega is, but if the amplitude is negative, then it's going to start negative and then work its way up to be positive for a bit, and then go back down to finish at the starting y. Alright? You may need to, there's a lot of stuff here graphically. You may need to go back and pause this, take a look at these, review these a few times. I'm giving you a lot of information in this one. So review and do a little bit of practice. Ask if you have any questions. Put something in the comments here if something is really not clicking, or talk to me, and I'm sure you will do awesome.